All right. We should be live now. All right. So, good morning, everyone, and welcome to our monthly query research progress update of the KNoWS group at Ghent University. So we've been doing these monthly updates for a while now, but it's now the first time we do it live as well. So the high-level goal of our group of researchers here at Ghent University is to hide away the complexities for reading and writing for application developers that want to interact with decentralized knowledge graphs on the web. And we do this by investigating some techniques to achieve efficient read-write abstractions over such decentralized data environments. So to achieve this high-level goal, we have the following people working on various subtopics. That we won't go into detail on each of these topics now, because each person will be able to have their say in a couple of minutes. So the format of these meetings is as follows. So each person who was listed on the slide before has a chance to present 3 slides in around 5 minutes, where the first slide is about the high-level goal of this researcher. Then the next slide will be about the accomplishments of the previous month, and then finally the targets for next month. And after each set of slides, we'll have a chance to have some brief discussion among all participants. And that's the format. Now, before we get started on going over these researchers, we have a special guest today who is Maxime Lecoq, who is an engineer at Inria, and he will share his work on querying with a shape-based indexing ontology. So Maxime, feel free to unmute yourself. I'll just stop screen sharing here so you can take over the screen. Now feel free to get started when you can.
Yes, you should see my screen now.
Yes.
Okay. So hello everyone. So today I will present our work that we did during the last 2 years about the use of indexes to search for data in a solid ecosystem. So first I will introduce the subject and the context, then I will talk about the results, and I will conclude with the future and perspective. So I'm Maxime Lecoq, research engineer at Inria. I work in the WeMix team with Fabien Grandon and Pierre-Antoine Champin. And the project was also a collaboration with the Stunted Blocks company. So we also worked with Benoît Alessandroni and Sylvain Lebon from Stunted Blocks. So we wanted to find solutions to find data in a solid ecosystem, which are as fast as possible and as well integrated with solid as possible. For instance, we wanted to be able to find freelancers into a set of communities of freelancers, given their name, skill, or locations. And we didn't want to change the solid protocol, so we decided to stay in the client-to-client protocols area, because solid is made of 2 kinds of protocols. So about our results, we tried to deploy distributed indexing, but it was very slow. So we finally moved to use federated indexes made with crawlers. It was much more faster. So you have a federated index that points to resource distributed all across the federation. And during our work, we encountered some limitations. For example, with Communica, because we rely a lot on Communica, which is very great, but we didn't manage to query named graphs, which are very important in the solid design. And also we didn't find a quick way, an easy way to handle query resuming. Our main deliverables are listed here, but I will briefly introduce the indexing ontology, for which there is a draft at the URL below. It's an RDF vocabulary to create indexes and meta-indexes, which are index of index. This vocabulary allows recursive querying and uses a reduced shape vocabulary. It's very simple. It's made of two main classes, index and index entry, with few properties. For instance, at the right, you have an example of an index made with this vocabulary. It's about people living in Paris. So you have two entries which are conforming to a shape that tells the properties the resource must have. And in this case, the resource must be people and living in Paris. So about the future, the project is ending at the end of September. So before that, I will publish a final draft of our vocabulary and a beta version of the library that we use to query, and finish the integration into the starting blocks framework and demo an app to search for traducers. And in a future project, there are many things that could be done. For example, handle pagination or query zooming, or propose a better version of our indexing agent. But our project is going to finish, so I'm not available as a freelancer, but you can still reach me at my Inria address before October, and then at my professional address or on GitHub or Git. Thank you.
All right. Thank you, Maxime. Maybe I'll first give a chance to Brian to ask you a question, since it's very related to your work, Brian.
Yes. I was wondering, is this this index, is it really tied to solid, or can you use it for multiple type of decentralized environment? Like for instance, if I just publish some RDF data.
Yeah, no, it's not tied to solid. You can use for everything.
Okay. And how do you sort of specify the region, yeah, the domain of your publication, of your data publication? So if you have multiple documents, how do you specify where they are?
So I didn't hear you.
Yeah, how do you specify in the network where are your data? So for instance, if you index apply to some sort of URI path, do you specify it somewhere, or?
Maxime, I think he refers to the property target that makes the link between the shape and where you find the actual data. But, yeah.
I guess what I'm trying to say is that if you have a data set with multiple files, you could, for instance, have a mapping with a shape for every file, or you could have a partial mapping, so you could have some files that are not mapped with your index. And I was just wondering if this current specification handles this case, if it tells you specifically that you are, that you don't map everything that you have published.
So in the current, I'm going to try to get the question, and Maxime, correct me if I'm wrong, but in the current proposal of Maxime, the vocabulary allows you to make the link between a shape and a source where you find data applying to that shape, which means when you design the shape, you actually choose which part of the data source you're going to index. If you don't provide a shape for some of the data of that source, these data will not be covered by the index. And we won't know that in that source, this shape is available if you don't do that in the index. So by designing the shape, you design the coverage of the index.
Okay, I think I see. Thank you.
Something I was wondering. So while you worked on this shape index, were there any difficulties that you encountered in the solid specifications, or recommendations you would have for future versions of the solid specifications that would have simplified your work? I'm asking because of the recently started linked web storage working group, which will build upon these solid specifications. So your lessons learned might be helpful as input to that group.
Yes, so I didn't find some limitations currently, because like I said, we stay in the client-to-client area, so we are free to do anything.
So in my opinion, maybe because we are free to do anything, that's one of the major problem is that you don't know when you arrive in an unknown domain, you don't know what to expect. So you don't know who is in charge of where are they going to be hosted, how are they going to be maintained, these indexes. The entire index ecosystem is completely open. And so this makes the entire processing and life cycle of the index very complex. So maybe in this new working group you mentioned, Ruben, a specific task or at least a specific discussion around the life cycle of the indexes themselves, and some of the recommendation in the W3C sense we could have on this index to make their discovery and update and refresh and things like that more efficient is probably a discussion we need to have.
Yeah, so there's a need for some kind of framework in which such indexes can be created. So not necessarily that the working group has to create these indexes, but more like guidelines on how such indexes could be created.
Yeah. So for instance, I mean, this is really just an example, and I am not advocating for that. But for instance, what is the entry point when a new client arrives and needs to discover the indexes? What is the entry point? Do we have one? What is the best practice to discover these indexes and to do it in an efficient way? That would be one question we could have. I'm not saying we should enforce a single entry point. This is open to discussion, but I think the topic needs to be discussed.
No, that makes sense. Okay, any other questions for Maxime?
I actually have one. So when you mentioned the challenges or something around querying named graphs in Communica, was it related to using Communica as a Sparkle endpoint or just as a client-side query engine? How?
Yes, we were using the client-side query engine. And we try to query the different documents, but we weren't able to say that we want to search only in that document or in that other one. But it's very we need to do this for solid applications.
So I guess you were referring there to
I forgot to
make use of the assumption that named graphs correspond to the document URLs, right? Yeah. Well, yeah, that's an assumption that could be made in the solid ecosystem, but yeah, Communica doesn't do that by default at the moment. Yeah.
Yeah, because otherwise Communica it was searching in all the source we were giving to it, so it was very long to get results.
No.
There's a question in the chat. I don't know if you can
see it. Do you want to forward the question?
How do I forward it?
Just say it.
Okay, so there's Mohammed asking in the chat if the does the index also embed the access control specs? If not, can it do it?
The question is about access control?
Yeah, I guess the question is if the access control can be embedded into the index itself.
Yes, you can put access control on the indexes.
So maybe just to add to that, the current ontology does not provide you any ontological primitives for that. So this is not covered by the ontology, but you have a very important point here is again, if you consider the life cycle of an index, the question of indexing public sources versus restricted sources versus fully private sources is going to be a problem. And it's going to be a problem for the indexes themselves and for whatever solution you choose, for instance, the crawling. So yes, we haven't covered that in the current system. We have a fully open index and fully open data.
Yeah, well, one option could be to place the index itself behind an authentication layer so that the index is personalized based on who views it. But then, you may have difficulties where you may have to regenerate the index on the fly, so you may need some smart caching mechanisms to speed that up. Okay, good. If no other questions, let me share my screen again. There we go. So yeah, thanks Maxime for your nice presentation. Then we can now go over to the different researchers here at the KNoWS group. And the first one on the list is Elias. Elias, the floor is yours.
Great. So hello, everyone. I'm working on a bit more of an applied problem and looking at how we can store genome data in a more sort of useful way. And I'm looking at doing that through representing it as RDF and linked data. Eventually, I will get to the querying of that data in a decentralized environment. But as of right now, I'm more working on the representation part. The specific questions that are guiding my research at this point are, why is data usage for genomic data a problem right now? And so I'm writing a review paper on that sort of issue and highlighting some of the limitations in the field currently. I'm also looking at building interfaces, user interfaces with solid data so that I can build in sort of like a testing mechanism for my future work in RDF representation of genome data. And we're doing that in an application called the Triple App. And then I'm setting up the environment to do this RDF translation and representation testing. Next slide. What I've worked on in the past month, I had an FWO fellowship, which is a PhD fellowship offered by the Flemish government. I had an interview, and that went pretty well, I think. The results will be in a couple weeks now, so fingers crossed. I've also been working quite diligently on adding an interface for privacy editing of data in solid pods. I have a demo of that coming up. I'm getting there. I'm still a little bit away, but I have a good direction on where I'm going. And then I am finalizing this review paper, which is a lot of work, but hopefully we'll get the sort of formal inquiries to journals in the coming weeks. And then my next target. So need to actually finish the review paper and hopefully get it submitted so that it can get into review and hopefully get published eventually. I need to finish up this triple application functionality so I can give the demo at a consortium meeting in early October. And then I am actively working on getting this server environment set up so that I can do the genome data experimentation with solid pods. And that is through my co-promoter Vito, and it's a lot of bureaucracy that I need to fight my way through. So I look forward to that. That's all for me.
Okay, great. Thanks, Elias. Any questions for Elias?
Yes.
Go ahead, Brian.
I have a small question, because you said, at least at the beginning, that the main of your project is how to represent genomic data into RDF, and I was wondering what currently you are doing in that sense, because yeah, we heard about the app and other stuff, but we didn't heard a lot about genome, at least maybe I didn't listen correctly.
Yeah, that's more, I need to get the environment set up so that I can do the actual translation and like have somewhere to put this graphical representation of genome data. There are existing ontologies that aren't complete, so my next steps in that regard are going to be looking at extending the ontologies for my needs, and so then I need to sit down and figure out explicitly what my needs are. And then, yeah, from there, just automating that process. So then I need to have a talk with some of our colleagues at Ghent about doing that conversion process using RML or whatever I decide on doing. But yeah, I'm getting there, Brian. Now hold your horses a little bit.
Just I think it's really interesting, so I want to know about it. And I guess for your context is personalized medicine, right?
Yes, yeah. The use case is so that physicians and patients and third-party applications can actually use the genomic data rather than it being stuck somewhere behind multiple firewalls in some hospital database, if the user specifies that's what they want.
Okay. Thanks a lot. Thank you.
Mm-hmm. But stay tuned.
These genome pods that you are going to set up, are these like what will the software exactly look like?
So I'm going to be developing a framework for setting up a proof of concept like server. So essentially it's what it could look like in practice. So there will be a server of many patient pods with a web application interface for adding data, editing the privacy of data, and then specifying different sort of privacy restrictions over different parts of the data, and then querying the data itself. So it's a mixture of specifying how the storage looks so that an application can work on top of it. Does that answer your question?
Yeah, okay, thanks. If there are no other questions for Elias, we will move to Brian. Over to you.
Okay. So hi everyone. So my main goal, my PhD topic, is to optimize traversal queries using explicit data publication structure. So more concretely, when data publisher or people, when they publish their data, they often have some sort of structure, either this implicit or explicit. And what I want to do is to use them to be able to either reduce our search space when we are traversing the web, or to do some query planning in the future. But right now I'm mainly focused on reducing the search space using RDF data shape mapping, so a bit like what Maxime is doing right now. So we can go to the next slide. So I've worked on two main topics this month. The first one is to do some query optimization with RDF shape mapping that I call this some sort of RDF data shape summaries, because we're sort of summarizing the data, so what is inside of those data sources and where they are located. So the first thing that I've worked on is a mechanism to associate the shape with our query to see if our data source might produce some query relevant information. So to do that, I work on a containment algorithm. So it's inspired, strongly inspired from query containment. So what I do is I take a shape, I translate it into SPARQL algebra, and then I have my query that I divided into star pattern, and I'm trying to see if they are contained within each other. So I finished this algorithm, at least for the context of my work, because there is, SPARQL is really complicated, so there's a lot of stuff that can be done, but yeah, for the moment I will scope it to that point. Other than that, I work on standardizing and generalizing my approach in the form of a specification that we call the shape index specification. So it has a lot of similarity with what Maxime has done, but I think it has some differences. Also, I try to focus more on query optimization. So there's also this angle that is a bit different. And lastly, I focus on scientific communication. So I'm working on a paper about that, where I'm going to formalize my approach, do some experiment, also evaluate the versatility of the approach, because since we are working on the web, we cannot assume that everyone's going to have those indexes. We cannot assume that those indexes will be complete. Also the quality of the index can differ. I mean, they will always be valid, but we can have shapes that are more descriptive than another, and how can we exploit it into our query processing. So the second part that I've worked on, or the second topic, is to do some schema alignment while doing traversal queries. So basically, if we have a data set that is expressed using another vocabulary, how can we query it in a traversal way and still getting those results? So yeah, I spent a lot of time trying to renovate a experimental implementation of doing reasoning while doing traversal queries, but I realized after talking also with the person who did this that it would be better to take another direction and to use the entry store and to do some modification into it to be able to do it, to have those online reasoning, so to do what we call incremental maintenance. And we can go to the next slide. So my next target for this month, or the next month, is I'm going to go to AMW. It's a conference. I'm going to present my paper and to watch the presentation. I'm also going to work a lot on benchmarking. So firstly, I would have to do some pull requests to push some code about it. So the first thing that I need to do is to finish my shape index fragmenter. So it's some software to generate the shape indexes inside of the benchmark that we are using. I also want to have more statistical data when we benchmarks. I'm also going to make some change into that, and I also want to have more data model, because our current benchmark only it has really few data model. And what the main advantage of my method is to be able to prune some type of data. So we would want to have more diverse data model. So I'm also going, the experiment I'm going to do is to test our benchmark with the data dump. So put everything to one sources and execute a query to see, to make sure that our results are valid, and also to see some sort of limit about it. And I also want to have a source selection or oracle, so to see the best query execution time that we can have if we already know in advance where the data is going to be located. And like I said, I'm going to test that activity and also redo the state of the art for productivity and so on. Also plan to do a lot of writing to finish what I started, talk about the completeness of those queries, the conversion of shape into SPARQL algebra, and my containment problem. And also we'll work on some side project, which is the reasoning project that I talked about for the schema alignment, and also to convert GQL algebra into SPARQL algebra. And that's it for me. Thanks.
Okay, thanks, Brian. Before we go over to questions, Jonni and Brian, could you share the links to that type index and the paper in the Teams and YouTube chat so that people following can also check that? the links that are mentioned in the slides.
Apparently, I need to subscribe to that channel to be able to.
Better do that then. Yes, Fabian, you have a question.
Yes, thanks a lot for the presentation. So, Brian, you mentioned the fact you want to do online reasoning during the Link Traversal query processing, especially for the alignment. So how do you see things? Because if you start to do an LTQP, and in the middle of that LTQP, you discover an alignment, what is your strategy? Do you use that alignment from that moment on, or do you revise what you've been doing already in the LTQP before you actually discovered the alignment?
I'm not fully sure right now how I'm going to do it. I think that we are probably the user could provide some rules for the alignment, and then those rules will apply to every data source that we're going to encounter. But I'm guessing if we, for instance, in a pod or whatever data source, if we discover new rules, maybe we probably want for it to be scoped so that the data provider say that in my data set, those rules apply. So it's probably something like that we are going to do, but I still need to figure out how to implement this reasoning inside of Link Traversal, and at least I hope that those challenges will be less fundamental or less, at least it will be a different kind of challenge. But yeah, okay, I'm not fully sure, but I think this approach will be what I do.
Okay, so so if I understand well, you will only consider local alignment, scopes alignment for a given source.
Yes, I think the users and the query can have some global rules, and I think the rule that we're going to discover are going to be local.
Okay, thank you.
Well, I wouldn't throw that option out yet, because from a research perspective, the case that Fabien mentioned is very interesting, of course.
Yeah, I agree. I agree too. I just feel I'm pretty sure that there could be some contradiction if you decide that everything is global, then you might get some problem with that. But
you won't get contradiction, because if you stay at an alignment with an RDFS entailment, for instance, you know that you are going to remain monotonous. So you know that everything that was true before will remain true. There will be no contradiction, but you may have missed things. And so I was thinking that if you save your plan, and if you save the plan execution, you could have the opportunity to revise it to see where in that plan execution you could have benefited from that alignment before, and restart that branch just in case you've missed something. That would entail saving the entire plan execution, which may not be a good idea. I was trying to understand what was your purpose.
Yeah, that's very true, because I was thinking about reasoning in general, but yeah, for alignment we will not get contradiction. But I'm not there yet, so yeah, I don't have a really clear answer for the moment.
Just to be clear on my side, I didn't say you will never get contradiction. I say under certain regime or entailment such as RDFS, you will not. Of course, if you go, I don't know, if you go to OWL and you discover an alignment between two disjoint classes, you have a problem. But that's another story, and it's probably not useful to spend time on a case which will happen, almost never happened anyway. But yeah, okay, thanks for the answer.
Thank you for the question.
Okay, any other questions for Brian? So in the previous slide, you mentioned here that this containment algorithm was limited to a certain subset of the Sparkle specification. Can you explain a bit what this subset is?
Yes. So right now I don't support minus operator. Also don't support filter not, and there is some property path combination that there is a bug, but I'm not fully sure what it is, and it doesn't really happen frequently. It's mainly when you mix a lot of sequence with alternative, combined with some sort of cardinality, quote-unquote cardinality, so the interrogation point and the Klein star and stuff like that. But I still need to really, because yeah, for the context of the paper, it doesn't matter because it doesn't really change the approach, but it's still interesting to really be clear particularly inside of the software, what is not supported right now, because it doesn't really change the approach that much.
So these are mostly implementation restrictions, but the algorithm is generic enough to cover the whole Sparkle spec.
Yes, because it's simply a containment algorithm. So of course, if you have more operator, then the complexity increase. I mean, yeah, at least the complexity of the concrete implementation will increase, but it will not change the method. But it's already a simplified problem because we are using shapes, and shape produce queries with clear assumptions. But yeah.
Okay, thanks, Brian.
Thanks for the question.
If there are no other questions, we will move over to the next person, and that's Maarten, but he has some trouble with the Belgian trains here at the moment, so he could not make it on time, so we'll have to skip him. And the next person is Ruben.
All right, so my high-level goal is to use the fact that we have a client-side engine that does query optimization for future queries. So we can use some patterns that might show up for users to optimize our queries. So what I did is a camera-ready presentation for an IMW paper. So in this paper we introduce a metric which sort of measures only the algorithmic performance of link prioritization algorithms, independent of any other optimizations or implementations. So that's pretty cool. It has very minor benchmarks so far. So I'm still working on a proper paper with extensive benchmarks of various algorithms. So to do so, I did some pull requests for Communica. The first is where we have a statistics tracking system where you can call a statistic and update it in whatever query execution part you want to track, and it will then emit this data to other parts of Communica by listening with a function. So this should help in various tracking systems or for adaptive query processing. Then following that, I worked on the extension of this system, which will do transformations over intermediate binding streams. So Communica sort of chains together binding streams or iterators and uses that to produce results. But if you want access to these intermediate iterators, that's kind of difficult right now. So this pull request will make this easier and sort of allow you to transform each of these intermediate streams. You can use that for intermediate result tracking, which is also used for adaptive query processing and the metric. So that is under review, but it is the approach itself is decent enough. And finally, for some optimization algorithms and not just metrics and pull requests, I'm working on joint sampling. So I implemented a paper, which is cardinality estimation done right, which is for SQL, but Sparkle is kind of the same. And my idea is to use this during link traversal over a cache of data that we obtained in previous executions, because we can use this cache to inform our join optimization approach, and hopefully that works. So this figure here is kind of how it works. You have a sample S, you look in the index of the RDF store that you have currently, you don't materialize any joins, but you only randomly sample from this index, so you don't have to do materialization. You can still select the size of the join that you want. So my next targets will be to present my IMW paper, which will be shortly, and to get the transformation of iterators pull request merged, which hopefully also wouldn't take too long. And then in terms of joint sampling, I still need to implement some dynamic programming because I have the cardinality estimations now, and I just need to use them. And did some research. I think the DPCCP is currently the best one. That isn't super difficult to implement, so I'll probably use that. And then if that works, I'll use this Link Traversal hopefully. And then finally, I want to implement a system that tracks the traverse topology, for which I will use the previously mentioned PRs. And this traverse topology can then be used for my metric and for more extensive benchmarks using the new Communica version and different implementations of link prioritization algorithms. So that was it.
Okay, thanks, Ruben. The AMW workshop, when is it again?
It starts the 2nd of October. I'm pretty sure.
Oh, so it's quite soon. Oh.
Yeah.
Okay, good. Any other questions for Ruben?
Yes.
Yes.
I was wondering, when you talk about re-execution of queries, so do you sort of, is it one big cache or it's a cache by the query that you executed? And do you also consider that the data source might have been updated when you want to re-execute the query?
So it will be one big cache, but I guess you keep track of what type of data or query is used to get the data, something like this. And then for updating, not really yet. It's still part I should look at. But first I want to get some idea of if the cache can actually work even in correct data. But then you can start invalidating parts of the data and see the effect of the algorithms that might help. Because if you have a document, you can use the E tag when you dereference it and compare it to the E tag you have in the cache, which would probably show if it's relevant or not.
Thank you.
See, Fabien has a question.
Very quick question, more of an understanding. What exactly, can you go back on the statistics? Because I'm not completely sure what you are building in the statistics. And I'm interested in your opinion, because I see you mention the statistic, maybe the fact that you will keep them. And so there is a relation for me between statistics you may build and statistic we may have in an index, especially if someone pays the price of building some statistics for a given query resolution. It may be interesting to save some of the statistics in index structure to save time for the next one. So I wanted to understand exactly what you were doing with your statistics and their persistence.
Right. So currently the statistics are mainly for benchmarking and getting insights into query execution. Things like when you discover a link or when you dereference a link. But it's a sort of general system that can be used also for calculating various other statistics about the sort of accuracy of the join plan or how many intermediate results are produced, which could then probably be saved. Yeah.
So it's more a benchmarking statistics than an actual statistics that could be used for optimized query planning. Okay, I understand. Thanks.
Yeah.
Sorry.
Okay. If no further questions, let's move over to Jonni. The floor is yours.
Okay, so my current high-level goal is to investigate various client-side adaptive techniques for link traversal over heterogeneous interfaces. So basically how to, upon discovering new information about the data or new data sources that might contain new data or some of the existing data in different formats, how to incorporate those into the query execution. So yeah, but within the past month, I have actually not done much research. I have been looking into making Communica limit the number of requests that it sends to servers based on the server replies, because while testing out some queries across a few Sparkle endpoints by running into the issue of Communica spamming the endpoints as fast as it could until the endpoints basically stopped responding. So the query obviously didn't finish at all. And the solution to this is to ensure that Communica properly handles the HTTP status codes. For example, the 429, which is literally the server telling it to not send as many requests. So that's more of a bug fix, I would imagine. But then I have also looked into automatically scaling the number of requests and the number of concurrent requests, because some endpoints, for example, the big data one, they allow a specific number of concurrent requests per IP and user agent combination. So, but I actually couldn't figure out where they would state this. I haven't checked the robots.txt. Maybe I should. Maybe it's there. But the best solution would be to discover these limits automatically by basically checking how fast the server can reply, and then scaling the requests up and down based on that. And yeah, and then also, which is unrelated to the previous points, but related to other work, I have been looking into the unit tests in Communica, and also system tests and other testing, because currently it doesn't actually test everything in the CI, which means that for most new pull requests that touch existing behavior, you need to run some manual testing in addition to the CI, which takes some time and it can add up quickly. So it would be nice to have everything tested automatically. So yeah, and then my next, yeah. So my next targets are to first finish the testing adjustments, because that should make everything else go faster. And then I'm working on basically continuing the work of Ruben Taelman from earlier this year around void descriptions by doing some refactoring to ensure that void descriptions in Communica are supported outside Sparkle endpoints, because currently the implementation assumes that the void description is part of a Sparkle service description, but the void specification doesn't necessitate it. So that's something I started last month, but I still have to finish it.
So that's to possibly use it in a solid environment.
Yes, for example, solid, or even in a TPF endpoint. I have no idea how it would work, but basically any anything that outputs any quads and allows serializing those descriptions. Yeah. And then I also want to finish an initial prototype of a very naive dataset deduplication approach using void. For example, if the same dataset is available as files and as a Sparkle endpoint, using the void description, if it would be possible to define for example, a URI space, and then basically assume that everything under that URI space is only available through a specific interface. But it's really naive. I think last month, I forgot who it was, pointed out that there has been research done by others to take into account the actual data itself, but it seems like it would be very complex. So, yeah. And then I also need to check if the solid bench server count scaling has any unexpected impact because one of our colleagues did some testing with a different number of solid servers. So assuming the scaling doesn't follow the patterns you would expect it to follow, then maybe there's something to report. Yeah, and then I also want to check if the request scaling has any impact that's worth reporting. And then I also have to retarget that paper, which ended up being more of an engineering paper than a research one. So I have to retarget it to an engineering, well, more of an engineering component. And that's it.
Okay, thanks, Jonni. On the previous slides, you were talking here about avoiding overloading servers, and there you mentioned that you had difficulties figuring out with Wikidata what the allowed concurrency was. Did you encounter any similar problems where it would have been helpful if the server communicated some more information?
Well,
because that could be input to future working groups that focus on, for example, the Sparkle service description, where that could be an option to include that in the description.
Maybe, but then the issue is that it should be something that's portable across different interfaces. For example, a server that only hands out documents containing linked data is probably able to respond to quite a few more requests, but then the server doesn't really have an entry point of sorts. So I don't know how it would be possible to make it usable or to make the information discoverable across all different types of interfaces.
No, so something like robots.txt or maybe
Yes.
even a void description. Right.
So I think a robots.txt would, if that one would allow it. I had a look at the HTTP headers, but there didn't seem to be any header that would allow the server to communicate it.
No. Okay. Any other questions for Jonni? Yes, Brad.
Can we go to the next slide? Yeah, I'm not sure I understand the check whether solid bench server count scaling as unexpected and word reporting. What is the experiment that has been done?
It's basically something Vim did. I think it was for the solid-lab project. So they did some performance testing with 1, 8, 16, and 32 servers. They basically just ran the default solid bench benchmark, but with the data actually spread across that many actual servers, so not just the local ones, but across different virtual machines. So I had a look at the results earlier, and they seemed like something one would expect. As in, it didn't dramatically, I think, improve the performance, but some queries that had to combine data from multiple servers were, I forgot if they were faster or slower, but yeah. So it was basically something that they benchmarked, and we were wondering if it's possible to write a paper about it. But to write a paper about it, it would have to contribute something. Like, there would have to be something that is worth reporting.
Okay, so if I understand well, they done similar experiment that what we do when we do a query experiment with the benchmark, where they actually spread the data into multiple servers, and they try to figure out if the solid community server, what is the performance of the solid community server in more realistic circumstances?
Not really about the solid server, but the query performance. So it's like instead of all the requests being sent to the same actual server, they were sent to multiple servers, but that's only the data access part. So it's more. I think it was more of a query benchmark.
Okay, and they measure if and they had some artificial latency or something like that to see if it changed.
No, it was. That's the impression I had when I was chatting with.
But it could be done.
Yes.
That was part of the plan, right? Yeah.
But I'm not sure if it will provide any insights beyond stuff like increasing latency, increases query execution time.
But I mean, depending if you have different reachability criteria, maybe, or different prioritization, maybe it can change something if you have latency. But I don't know, but I guess maybe it can change something.
Well, it can definitely matter if you have replicated data. Like if you have the same data in different solid pods and you suddenly notice, one of the pods here has a very high delay, then you can have an intelligent algorithm that decides to not go to that pod anymore, but instead go to the different one that has a lower latency. So that could be a next step there to look at.
It has answered my question. Thanks a lot.
Okay. If there are no further questions, we can go over to me. So I'll keep it short because we're almost out of time. So in order to achieve efficient read-write abstractions over decentralized data environments, next to helping the other PhD students, I focus on designing algorithms and data structures for decentralized querying. So what I did in the previous month was mainly two things. First, I helped out a bit in the REF* working group with some small pull requests to update the specs, and next to that I also started implementing or started updating the Sparkle.js parser for the Sparkle syntax to handle the new reifier syntax that is being considered now in the working group. I'm mostly done with that. I just need to do a little bit more testing. Next to that, I also worked a little bit on preparing a new release for Communica, where the main focus was on a bunch of smaller changes and refactorings that can positively impact performance. So I included some figures here on the slide where you see the evolution of performance of Communica across different benchmarks. There is some variation in the figures due to external factors, but overall you can see that execution times nicely go down, especially here the bottom left figure, which is the Berlin Sparkle benchmark. You see that from the start of our measurements, execution time has almost halved. So that's a nice improvement there. So my next target for the upcoming month is to continue working on things for the RDF* working group. I'll mainly be adding some spec tests for the Sparkle syntax there, based on the implementation I worked on in Sparkle.js. Then the plan is to release version 4 of Communica around October 14 with all of these performance improvements. And next to that, I also want to continue with preparing a new lecture on web scripting for the web development course here at Ghent University. I recorded some videos for that, so I need to edit them and then put them online. And that is all for me. Any questions, either for me or in general? Okay, if all is clear, that brings us to the end of today's progress update. So thank you all for joining, and especially also Maxime for joining today as our special guest. So for our next progress update, so these updates are monthly. They recur every last Tuesday of each month, every time at 9:30 Brussels time. Which means that the next update will be on October 29 at 9:30. So I hope to see many of you there again. So yeah, unless there are any final comments or questions, we'll leave it at that for today. Thanks all for joining. See you.